We're super excited today to welcome Soe Min. Soe Min is currently the head of engineering at a cybersecurity startup called watchTowr. And Soe Min has been there for uh, uh, about a year now. Prior to watchTowr, Soe Min was a lead engineer at Stashaway, so a company some of us are familiar with because we hosted Stashaway CTO Nino a couple of weeks ago. And at Stashaway, Soe Min was responsible for developing the onboarding process and developing tools for engineers to work more efficiently. And he was at Stashaway for over almost 3 years. Prior to Stashaway, Soe Min is actually a career switcher. So like many of us here, Soe Min did not study computer science in university. He actually studied mechanical engineering at NUS, National University of Singapore. And he went through General Assembly in 2017, General Assembly's coding bootcamp, to transition to be a software engineer, where he worked at a few companies before Stashaway and watchTowr. Prior to being a software engineer, Soe Min was a design engineer at companies like Technip and FMC Technologies. Super excited to welcome Soe Min today. He's going to be sharing with us some ideas from his current company, watchTowr, around making secure software. And of course, he'll also be able to share more about his journey as a software engineer, transitioning to software engineering from a non-computer science background. So super excited. Welcome, Soe Min. I'm going to hand it off to you for presentation.
Thanks. Thank you so much, Kai.
Cool.
And thanks for the welcome. I'll share my screen right now, then start the presentation. All right, so let's start. So right now, I'm the head of engineering at watchTowr, and how this will flow is I'll kind of introduce myself, and then after that, a little bit about the company, and then we'll talk about lastly about horizontal scaling and why it's important as a technique when you want to run things in production, especially in companies like Stashaway and watchTowr, where there's a lot of processes that needs to be done, and you cannot just have like one server to handle all of them. And about myself, Kai actually said almost everything that that I wanted to say, but it's fine. Let me just rephrase some parts of it. So one thing I also want to highlight is that even though I studied mechanical engineering, I tried to learn coding like multiple times in the past. So like, you just go through like online like Codecademy, or through like online courses to kind of try and understand what coding is. And then I learned like JavaScript maybe 2 or 3 times, and then I done like Java, I done like Python like a few times, but never really stick, right? Because you're not really doing a proper switch over to like software engineering. So you learn and then you forget, you learn and then you forget. So then I realized that doing all these, it didn't really help me with the switch that much. I really had to like dedicate proper time and like and do projects with other people, like through the bootcamp, or through like yourself, where you guys have a like group-based assignments where you can actually deliver a product instead of just following through a tutorial, like what you see on certain online I guess assignments. And I also kind of participated in a few other like hackathons, which are just coding competition in general, just to keep my mind sharp. And then after that, I did all those kind of before General Assembly, just on and off, but never really fully transitioning, because like it wasn't enough to kind of the switch is actually quite steep. So but once you attend something more structured, and then they tell you exactly like these are the stuff you learn. Yeah, this is how you like do your resume, how you apply, what's important. Then after that, you can overcome that first bump, and then after that it's a lot easier from then onwards, because then you are already recognized as like a software engineer, and then it's easier to kind of like move on to other software engineering roles, instead of like this guy is just showing me that he knows JavaScript or TypeScript, for example. But then like he has no background on it, so it's very hard to trust this kind of guy. But then after that switch from general assembly, and I moved to startup. So I first started at Canvas, which is a local like Martech company, kind of. And then after that, I moved to Stashaway, and then now I'm at watchTowr, and it's all focused on building products. So that was kind of my interest from the start. So I wanted to build products. I wanted to own a product that I can call like my own, or that I can kind of like keep developing on and improving on throughout the years that I'm with the company. Instead of like doing things for other people, like let's say for example, I built a product for this other company, and then after that I move on to another product. So I wanted to do something that is that I can see through all the way from idea generation to building it, to the maintenance, as well as all the aspects of it, like front to end. So that was kind of like how I kind of position myself as an engineer, as a product engineer that is experienced in building products from scratch, and also maintaining the products, and not just like consultant based, where I do something and then I hand over. So that's kind of like my career at a glance so far. Next, I'm pretty sure you guys have more questions, but I'll address them at the end. So next I'll talk a little bit about watchTowr. So watchTowr is a cybersecurity technology company. So what does that mean, right? It's so traditionally cybersecurity companies in the region are mostly like penetration testing companies, or companies that like maybe are selling a software, for example. So watchTowr is more of a platform that we provide a service to our clients. And this service that we're providing is real-time attack surface discovery and continuous assurance. Like I'll talk a bit more about what this jargon mean in the next few slides, and give you guys a brief introduction to what is cybersecurity, and how do we identify that a company is vulnerable. And then lastly, I'll talk a little bit about how we scale this with technology. So let's start with the first part, which is attack surface. So what's an attack surface, right? Like attack surface is essentially the boundary of your system that you need to protect against attackers. So for example, let's say I'm sure you guys use like the tools that I have kind of highlighted in the diagrams there. So there's like the ones like a mobile app, like a website, a database, a server. These are considered, I guess, traditional attack surfaces that people usually attribute to a company. And then after that, on the left side, you have like Slack, you have like Docker Hub, you have like GitHub, you have like Postman workspaces. These are also considered attack surfaces because, like, let's say for example, if your company is running a Slack instance and then an attacker gets into the Slack instance and manage to find information about your company, information about your clients on Slack, for example, then that is a potential attack vector where people can extract data from your company to kind of like use in malicious ways. Same for GitHub as well. Let's say for example, if I check your GitHubs right now, have you guys committed any secrets to your GitHub? Have you committed? I'm pretty sure you guys have. like every dev have made that mistake, like maybe the first few times. But then but like secrets are one of them. The other ones are like API keys or code that like bypass code that that you might write, but then you make it public, so like other people know how to attack your application in a more efficient way. And there's also things like Postman workspaces. If you there are ways to share API details with like your teammates, but many times these are not properly secured, so people can go in and then find also keys in there. And last, like I'm not sure if you guys have used Docker.
Most of us haven't during the course. Yeah.
Okay, then I'll skip away. But essentially, it's like how you bundle your application, and then you can have like it can also be accessed from outside if you don't do it properly. But then what you guys will be mostly familiar with is like your servers, for example, like your node server, is exposed to the internet, and then your node server got routes, and some of them need to be authenticated, some of them are not authenticated, and if they are not authenticated, then are they giving out information that they shouldn't be? So all these kind of like encompasses your product's attack surface, and there are definitely a lot more, but I kind of scope it down to what you guys are familiar with. And these are all attack vectors that a malicious party can then come in and then and get data from your company or do something that will disrupt your services. And next is assurance. So assurance is knowing that all these companies, all these products that you have put into online are safe. So I wrote a few recent attack techniques around the attack surface. So what is a CVE, right? CVE is a, I guess, industry specific library of attack techniques. So it stands for common vulnerabilities and exploits, and it's maintained by, I think, the US government, one of their branches. So what it is it's an open source list of ways to attack a specific a specific service. So for example, just yesterday, a CVE got released for Confluence. Yesterday night.
Wow.
Yesterday night.
Dear.
So
should we fix?
So this is that depends on how you set up your Confluence. If it's, I believe it's for self-hosted Confluence, and if you so the notice just went out yesterday night, and then Confluence said, or at least which is the parent company of Confluence, said, if you guys have set it up this way, you need to take it down like right now, because the security is highly critical, and it allows an attacker to access, bypass your the authentication and kind of like get data out from your Confluence environment. So this is like a real scenario where it just happened yesterday night, and then so what watchTowr does is this attack technique just dropped. So what we need to do is we need to then let our clients know, are you vulnerable to this technique? Right. So the first thing you need to do is you need to know whether the client is actually running a Confluence server or not. So that is part of the first part where we identify attack services. So if let's say, for example, none of our clients are using Confluence, right? Then they are by that logic, they are already not vulnerable. But if they are, then we need to kind of do a check to check whether their version of Confluence is vulnerable or not. So this is kind of known as a 0-day attack, because it's 0-day because the defenders or the people that have that service have no time to react to it, essentially, because they know how to react to it the same time as the attackers know how to react to it. That means the moment the attackers know that this attack exists, and then they know that you have this service, they can then start using it straight away, provided if you haven't patched it up. So that's why right now, since I'm not sure if there's a patch released already, but from my understanding, like this morning, the recommendation was just bring down your Confluence servers and wait for the patch.
Okay.
So that is kind of assurance, like where you look at your attack surface and then check whether each of them are vulnerable to any specific vulnerabilities or not. So then the last point is like, how can we be faster than our adversaries, right? So let's say, for example, the example this morning, right, where the CVE for Confluence came out. How can we know that we are not affected or we are affected? You cannot have one person monitoring the system all the time and go and check through every single system. Like if you're a big company, there's like hundreds of services that you use across multiple countries. It's impossible to identify all the tech services like every time something happens. So we need to automate. So we need to automate certain parts of it, and then and certain parts we need to have security engineers to keep everything in check, because automation is not there's no logic that can encompass the knowledge of a server security engineer. So and there's generally two steps. Like first is to identify the attack surface, and next is to test the attack surface for vulnerabilities. So the first part is where you try and find whether there's a confluence. Let's say, for example, you use the same example as what I mentioned. Confluence is, to explain confluence. Confluence is like Notion. So if you guys use Notion or maybe or kind of like Google Docs, I guess. Like,
we use all of those.
Okay, yeah. So essentially, it's a place where you can store. There can be sensitive data inside, especially in large companies where you do keep you use it for sensitive information. So the first step is to identify whether your company has confluence inside, and we use a variety of techniques to do that. So each technique is usually run by a server or a some kind of script, I guess, that we then automate. And this runs like continuously. So let's say, for example, if you have Notion today, and then tomorrow you switch to Confluence, the service will need to identify that Confluence has been added to your list of attack surfaces. So there needs to be a constant check in place to make sure that we identify assets in a fast enough fashion. And next, after you identify, is to test it for vulnerability. So the vulnerability that I mentioned just now, there is a way to kind of test it, like to test whether it can be done or not on your system, and this can also be slightly automated. So once we figure out how to automate it, we will automate it, and after that we kind of run that test on your service like throughout the period you have. So it's a never-ending loop of identification and testing, and this is constant. And you can imagine the amount of like processing power that's needed to do this kind of check, because you're running the servers like 24/7, and then there's like multiple clients, multiple assets, and I've only talked about one asset and one different type of vulnerability. But let's say if you have 100, thousands of assets, and then there are like hundreds and thousands of vulnerabilities, how do you then orchestrate the whole testing process so that your servers, you don't need like you cannot have just like one gigantic server, right? It's impossible to do everything. You'll be too slow in a sense. Like by the time the thread like finishes, like there's like the queue is gonna be longer than your server can process. So it will never end. So the answer that we have is through horizontal scaling. So horizontal scaling means instead of having one large server, you have the multiple smaller servers that can then you can have all these processes in parallel. So let's say, for example, if one server can have like a few parallel threads, and multiple servers can have like even more. So but then to do this, the servers all need to kind of like know how to communicate with each other and kind of work together, right? If you run everything in the same style as one server, then they might be doing the same thing, and then you're wasting even more resources in a way. So to do this part where servers know how to communicate and work together, one technique that you need is load balancing. So I'm not sure if you guys are familiar.
We don't know. We mostly, and I think most of us will know. We mostly use single servers for applications during the bootcamp. Yes, we haven't been exposed to things like load balancers yet. Which sure. Super excited that you're sharing this. Okay,
so I'll share a little bit then. A load balancer is essentially just another server that tells like the request. Let's say, for example, you have a web application, and then you have let's say you have maybe I take it back to the first part where you have one server and then another one server that is serving the web application, another server that's a server side. So if there's no load balancer, it will talk directly to the server, one-to-one, right? But let's say if you have two servers and maybe 2 or 3 users, which server should handle the request of the user whenever a request happens? And this concept where the user requests the load balancer, and the load balancer kind of tells passes a request to a server that has less load, and then the server processes load and then responds back to the user. So it kind of like helps to split the load. What kind of analogy would I use? It's like, let's say for example, you guys got play what do you call that, the cooking game, right? Where you got multiple people, and then they need wash a whole load of dishes, for example. And then you're the manager that's like assigning tasks, right? So you got like 10 dishes to wash, and you got three workers, right? You don't just give all the dishes to one worker, right? You dish 3 to one, 3 to another, and then like 4 to the unlucky one, I guess. So then you kind of split the load, and this is what the load balancer is like. To split the load from the request to the many different servers or workers that you have. There's a lot of different load balancers in place that can use, but you 100% you will encounter it the moment you go into into real world, and almost every single company that I work with have some kind of load balancer in place, be it handled by AWS or be it manually deployed, etc. So that's on the request side of things, where you have a very simple request, load balancer, and then the server. Then the other side, on the right side, where you can see a stack, is where we have a list of jobs to do, right? And then the load balancer kind of put these jobs to each server. So a job is kind of like a process that it can be anything. It's essentially very similar to a request. Let's say for example of a job is to send an email, right? Let's say this job is to send an email to Kai to let him know that a new student wants to enroll in Rocket Academy, right? And then whenever this job is picked up and done, the email is sent. So that's an example of like a job. Like it can be any kind of request, but instead of requesting by users, it's like a queue that we need to kind of go through.
Sounds like an attack.
It's kind of so. How do we then combine everything together that I've kind of explained to you? How is it done in practice? So in practice, right? So you have like a list of like modules that can use to identify assets. So for example, there's a task to identify whether a company has confluence every 5 minutes, right? So we take this task and then we put it in a queue, right? So in the queue there'll be please check if this company has confluence. Then maybe 5 minutes later, another similar task in the queue, and then the servers that can do this kind of check will pick up the job, right? They will pick up the job, and then they will perform some check to make sure whether this company has confluence or not, and then it will kind of like respond back to another service or some kind of state, like not some kind of place where you can store state for that result, essentially. Like when we talk about state, is anything that is persistent. So what you'll be familiar with will be the database itself. So let's say, for example, Mongo or Postgres, they are persistent. So so this persistence is called like state. Right, and then you have another group of modules that is used to identify whether, let's say for confluence, right, like whether it's vulnerable or not. So in the queue there'll be like we've identified that this company has confluence. Please check, that it is vulnerable or not. So then the queue will be filled up with all these requests, and then the servers that can do this kind of check will pick it up and then execute the code to do that check, and then after that return the result to a place where they can store state, and then after that we will then take the result of everything and then like tell our clients whether they're vulnerable or not. So this way, using like a queue to kind of orchestrate the processing, we can run like multiple servers instead of having one server with the queue inside, like handling everything upon request. But this one, there's kind of like a way to throttle the processing a little bit, but still be able to scale up. Like if we now in the picture you can see like 4 servers, right? But actually in practice it can be like 100 servers, right? Depending on how fast you want to go through the queue. Hopefully that gives you some brief understanding of the design pattern that we have for doing horizontal processing instead of having like one server. Yeah, that's it for me for the presentation.
Awesome.
I try and keep it a little bit simplified. Might be a little bit too simple, but yeah, happy to
I think that was perfect.
Take questions. Yeah, awesome.
Thanks for sharing, Soe Min. I think that was a good insight into the type of work that watchTowr does, right? Screening for these assets that people have, like Notion and Confluence, and then checking for all the vulnerabilities that are, especially the ones that are posted publicly by people like the US government, right? That's super, right? Because it gives people that peace of mind that, okay, all my stuff is secure. I'm sure I have a lot of questions around like how technically how things work, but I'm sure I mean, we can dig into that later. I'm sure we have other questions around your personal journey as well that we can dig into. So for everyone else, the Pigeonhole, I'm going to share the link again for those who just joined. So feel free to post your questions there. I see Therese and Gary have posted, which is great. I'm just going to kick things off by sharing some of my own questions. So that you explained a bunch of technical details around what the product does and generally how the queue works. So what kind of processes need to happen. Just curious from your own perspective, since you're the head of engineering at this cybersecurity company, right? How much of your work is security, like trying to understand these vulnerabilities, and how much of your work is infrastructure, like so-called developer operations, DevOps, right? Where you're managing all these queues, managing all these different servers, load balancers to make sure that the checks happen efficiently and accurately.
So for watchTowr, at least, we have a very strong cybersecurity like division, I guess, where they are former adversaries. So that means they are the guys that you originally call if you want to hack like an entire bank, for example. So some of these guys are very successful at that. So that means I can kind of offset the understanding of vulnerability to these guys and then focus on the automation aspect of things, where we take their knowledge and then we codify it and then create an environment where we can kind of multiply what they know and then apply it to more and more clients in a way. So my responsibility mostly lie in the automation and like, I guess, the client-facing aspect of things in terms of the product. Yeah. While cybersecurity research, we have like a research team, which are like cybersecurity engineers, and then they are the ones that kind of monitor the vulnerabilities in the wall. Some of them are actually creating vulnerability, creating attack techniques themselves. So we got an engineer that joined us recently. Then his role is to find zero-day vulnerabilities. So that means vulnerabilities that are not publicized yet. So that arm is the one that is kind of like more on the
Like a
security
security
side.
arm and there's an engineering
Yeah,
arm, essentially.
correct. So the engineering arm is the one that kind of automates, make sure that everything, like the processes can run in place. Yeah, and then like everything, all the data, essentially because the security techniques produce so much data, the data pipeline and the passing of data needs to happen like without failure and quickly as well. Because if anything along the pipeline is slow, then instead of telling our clients that they're vulnerable like now, maybe we tell them 1 hour later, and then they might be vulnerable. That means the window of vulnerability is increased, and we don't want that for our clients.
And so what you just shared is awesome, and it shows that you understand deeply how the vulnerabilities can be exploited as well as checked. How did you learn this knowledge as someone who didn't study this in university, right? You were working as a design engineer, went through a coding boot camp. It can't be that you learn all this stuff during your coding boot camp. So where did you learn this stuff, and how would you recommend we go about gaining more knowledge like this as we work?
Okay, I think I mean, when I first started, I kind of were a little bit lost like you guys on where to start, right? And the way I approached it was, you know, I mean, definitely I asked like people more senior than me, but I think what really helped me was that to understand that firstly you need to understand the language that you want to focus on first. It's very similar to learning a new language, right? Let's say English, for example. If you want to write like let's say you're gonna write a Shakespeare like something like a novel, you need to first know the language inside out, and then after that, when you read the next few steps, like when you read books about design patterns, when you read a little bit more complex books, then you can understand what they're saying, and your learning will be more efficient in a way. So I think what really helped me at the start was to focus on the language, understanding the intricacies of the language, and know, especially for if you guys are working on JavaScript, it can be there are a lot of ways to do certain things, and like whether you want to do it more OOP or functional or etc. There's a lot of different techniques, and you need to be familiar with the base language to kind of appreciate why certain things are being done a certain way when you look at the design patterns next. So I think that really helped me out in terms of being familiar with kind of the architectural aspect of things, where you start from the core building blocks and then you kind of build up. As for the rest of the stuff, like where DevOps, security, these things, some I was exposed because I was one of the earlier engineers in some of the companies that I was at. So if you work in a team of like 10, like and you're able to deliver your current role, definitely you'll be exposed to other aspects of the company. So I was a little bit fortunate in a sense that I managed to go in depth with one specific channel, but also brought in others to have some experience there that kind of helped me like have the footing to expand on that later on.
Well, that's interesting, right? Because you're saying you went in depth with learning JavaScript or the languages that you were specifically working on and the patterns there, but you also got the depth because you would join a startup, and because it's a startup, correct. There's no choice, right? You just have to do the DevOps. Nobody else to do it. If you're working at a big company, you may not have gotten that kind of broad experience, right?
Yeah, and the flexibility, I guess, in startups, it's more all about showing that you're capable of doing a certain thing, and then the next day you'll be asked to do that already. Like it's you don't need to go through like a long process. As long as you say I can do it, you can do it. Like so I like that kind of flexibility as well, where you don't need to go through like a lot of like processes to get something done, and startups are all about getting things done, right? Because the runway is like it's counted in the days, not weeks or years.
Mm.
Yeah.
Awesome. Yeah, I really love that. I mean, that's part of the reason why I joined a startup after I graduated as well. I'm going to move on to some questions from the Pigeonhole. Therese has a great question that is top voted. She says, Therese, Therese, why don't you want to share your question?
Oh, yeah. So you mentioned that you're a product-driven engineer, and I wanted to ask if you felt the same way when you were doing mechanical engineering. Or was there something special about software engineering and its flexibility, how you can push out products faster, that specifically made it more appealing to you?
I think the main difference is the speed of delivery. When I was a mechanical engineer, projects take like 2 years to complete. From design to fabrication to delivery to installation, it can take very long. And there's a lot more processes in a way. So I think in my first company, to get something out, even past the design phase, you need to go through like 4 design reviews, and each design review has like 5 to 10 engineers inside, and then you gotta like defend your design throughout the entire process. And then by the time and after that, it's all like you need to procure materials, you need to get the correct like people out to tell you how to build it, then how to assemble it. So in terms of the engineering and development process, right, it's very similar in a way. Where you have code reviews, you have like UAT testing, you have like automated testing, you have ways to specify acceptance criteria, and then verify that the acceptance criteria is met, and after that delivery, and then maintenance after that, right? But the speed of which it happens is like years apart. Software engineering, you can get it done in a week.
Sounds like the time scale is like a couple of years versus a couple of weeks.
Yeah, correct. It's very different, but what I learned was at least the engineering process and the discipline it's very similar. It's just how you look at it. Yeah.
Just to add on to my previous question, would you feel that your previous experience in product design has helped you as a software engineer?
I mean, there are some transferable skills. Like some of the math definitely not transferable, but the way we look at like developing a product, the way we look at processes, the way we write vigorous testing. So when I was a product engineer, I was designing equipment that you install underwater to extract. So when you install it, it's left there for like 30 years. So it's similar to like if you push code into a bank and then if it breaks, you lose money, right? So it's the same kind of highly critical like software or products that you need to build. So the rigorous testing is and kind of like thinking of ways where it can break is something that it can be also like brought forward. I mean, engineers are always very pessimistic, and that is by I think that is by training. Yeah.
So similar to how engineers might use like a factor of safety in their product design, is there anything that software engineers can do to make their code less vulnerable to, say, attacks, as you've mentioned?
I mean, if you're talking about JavaScript, there's definitely more ways to write like more defensive code. It's very different in terms of factors of safety because there's a lot more trade-offs in software where if you add too many checks and your processes are slower, and then there can be other problems that can go along with it. So I think on the factor of safety aspect, let me think. I mean, definitely there are ways to make it more defensive, but whether or not it's a must-have or must-not-have is a trade-off, and also understanding where to add these at these checks. Let's say, for example, if you're writing a service that have multiple layers, do you want to add the checks at the last layer or the top first layer? If you add it all at the first layer, then the layers after that, can you guarantee that these checks do not need to be repeated? So these are some questions that you need to answer yourself based on the scenario that you have. Let's say if you make it too defensive, right, and then your software just become very bloated, and then then you'll need to fix it some other way, and then like you have other problems.
Right.
So it's never a clear answer on this side. Yeah.
Mm-hmm. Thank you, Soe Min.
Awesome.
Yeah, no worries.
Thank you. I think there are a few questions around cybersecurity, generally your path to cybersecurity. So I see a trend in these questions, all personal, right? It's less technical and more personal. People are curious how to become like Soe Min. And so what sparked your interest in cybersecurity? It's a jump to go from, I guess, software engineering to cybersecurity, and what drove you to that specific domain of interest?
I guess for my side, because I was always working on products that like, let's say for the statuary, right? Like it's a highly critical application. Like it cannot break. Like if any vulnerability is found and then attackers break in, well, it's a business ending. It could be business ending in a sense.
Yeah.
So when you work with these highly critical systems, there's always you yourself will need to be aware of like the cybersecurity techniques to protect against it. So like OWASP top 10 is like like every engineer should know that. Yeah. But after that, there's like a few other techniques on how an application engineer should manage your servers or your clients. And for me, I was relatively fortunate in a sense that whenever we do like pen testing for the company, I could be part of it and also kind of like look at the report and understand how certain attacks can be made, so that we can then learn how to protect the company.
Just for everyone, in case people know, what pen testing stands for penetration testing, and is just trying to attack yourself basically to see where your gaps are.
Yeah. So most decent companies, they will perform penetration testing maybe twice a year or once a year to make sure that the software is solid. Because if a penetration tester can break in, any other malicious hacker can also break in. So you need to make sure. So this is always kind of like most companies do it, and I was kind of writing the software that is getting pen tested, right? So I kind of developed some interest there, and then when Ben and Sam from watchTowr approached me about creating a software that can automate the pen testing process or part of the pen testing, I was quite interested. And then after that, it was just it was where I am right now.
Teresa, does that answer your question?
Yes, definitely. Thank you.
And then Gary has a related question, right? What was your experience like transitioning from fintech into security? Was there a big difference in the skills? And Gary, please feel free to elaborate on the question as well.
Yeah, I think it's related to Teresa's question as well, where we're just curious, like what prompts you to jump. I think you were from statuary previously as well. So you went from fintech and then you jumped to cybersecurity. So was there any like any prompt that makes you actually transition to a different industry, or was it something like, oh, okay, this opportunity just so happened and yeah, I just want to try it out?
I think it was mostly pull factors from watchTowr that prompted me to join. I mean, they were building something disruptive, and I kind of quite like working on disruptive technology. So the guys that building a company are very experienced cybersecurity engineers. So what they lacked was the product engineering side of things. So that's where I can kind of like complement their skills, and then kind of build the engineering team to kind of support the cybersecurity side of things. In terms of the way we work between like fintech and cybersecurity technology is on the engineering side, it's not really that much different. In terms of the regulations that we need to comply to, in terms of the amount of security or that we need to put in place to protect ourselves as a cybersecurity company. Because let's say, for example, if we do get breached, then our clients will also then attackers will kind of know how to break into our clients, because we are kind of like storing information on how to break into our clients, right? So in terms of the amount of like in terms of protecting the assets of the company, is very similar to a company like Stashaway, where they also need a very rigorous like security team or processes in place. So it's all both very highly critical applications. So in terms of the engineers that we have, people that are familiar with working on this kind of mission critical services, and also people that are able to appreciate, that you need to, like, security is number one in terms of whatever we build.
Yeah, probably if you're working in a bank or even at a healthcare company or a hospital, that kind of healthcare thing, this kind of data integrity is super important as well, right?
Yeah, correct.
Gary,
No, go ahead.
Gary, does that answer your question?
Yeah, maybe just the final part, I think maybe you can give some advice. Like, I think you touched a little bit, right, where you actually learned a lot during your days back in the startup company. But if, let's say, someone want to, I think from a fresh graduate as a SWE, how do one actually like go into cybersecurity if one is interested in that domain? And is there any like relevant skills or knowledge that the person should pick up?
Are you referring to being like a cybersecurity engineer, or
yeah, maybe along the realm of cybersecurity engineer, or maybe like DevSecOps as well?
Yeah. I can't really give you too much advice on that, because my experience is mostly on engineering side of things. But yeah, the cybersecurity engineers in my company will probably be able to tell you a little. Of course, I'm the engineering complement to the cybersecurity team, so but I can ask them for you if you want. We actually also have internship positions for cybersecurity engineers open if you want. But it's an internship position. But I could ask them if they're willing to take any, because for that position there's no cybersecurity engineering experience needed. You just need to know how to code a bit of Python, and then you're fine. So if you want to go in through that style where you go in as an intern, maybe that's something that I can help you with. But in terms of how to actually transition to a cybersecurity engineer, that area I'm not so sure. I'm not 100% sure on that. Yeah.
Okay, thanks so much.
I can help you transition to a product engineer if you want.
Product engineer at a cybersecurity company sounds like a great learning experience.
Yeah.
It's the best of both worlds, I guess.
Yeah. Great.
Cool.
Okay.
I am just curious, open up to the floor. Based on what we've talked about so far about Soe Min's experiences as a product engineer, helping watchTowr scale the automated testing of vulnerabilities. Does anyone have any questions around maybe his experiences after General Assembly, his experiences at the companies that he used to work at? I have a question. That's usually it. What is the interview process like at watchTowr for product engineers, and what do you look out for?
Okay. So for product engineers, we try to avoid algorithm tests, what we usually do is we give a scenario, and then we ask you to design a ERD diagram based on the scenario. And this is kind of to understand how you think and relate items to each other. So let's say, for example, if I give you a scenario on what I presented just now, on then so given like all the attack services and the ways of testing them, how will you design the database model to encompass this process? Right. So that is a critical part of our technical testing, because ERE design or understanding of ERE design will translate a lot into the other parts of the application. So that's one part, and the other part is like if you're joining in as a more on the front end side of things, then the test will be more on how you look at a design and how will you then translate that into components. And so it's a lot on understanding the design of the product that's given to you, and then translating it and planning out, how will you then like break it down, because that will kind of show you how you think in terms of component structure, in terms of reusable components, in terms of how do you see natural hierarchies and the data flow in the application, which are all the more harder skills to pick up, I guess, in a way, compared to if you we don't want to just like design a component like and do CSS or anything like. The hard parts are looking at the component structure, looking at the data flow, the concepts, and how will you then like choke it based on like the information that's given to you. So that's sorry, go ahead.
No, go on.
So that's kind of like these two tests kind of encompasses the entire like technical interview, and after that the rest is kind of like cultural, team fit, kind of the usual. Just make sure you're a normal person, and then you'll be fine.
How does that and how does this differ from interview processes at other companies like Stashaway, for example? Are the things that people look for different?
I think for Stashaway, Stashaway also has an ERD exercise for most engineers. But Stashaway also has kind of have a take-home assignment that is, I think, for front engineers, that at least from what I remember, a little bit of coding involved and definitely a lot more rounds. The way we, as a startup right now, as a relatively like fast-moving startup, we wanna move very fast, and we wanna like we don't have time to give a take-home assignment and then wait like another week and then a few more weeks. So we can do everything in like a few days. The cycle of time is very, very fast. So, and then we also want to kind of like understand how you think on the spot, because like given an assignment, you don't have time to plan it out over a week or two period of time. Let's say we got to design out now, we're gonna develop in the afternoon, and then like the next day we push into production. That kind of speed that's what we're looking at. So you need someone that's comfortable with the pacing, and that's able to like think on the spot and react to the scenarios. And I also feel algorithm questions will weed out, not really weed out, but will discourage a lot of very good candidates from applying as well. So I try to avoid that, at least.
Why do you feel that way?
At least for my side, it's like algorithm questions, as long as you train for it, you can do it. You just need to like spend a few hours every day just do algorithm. Sooner or later you get it. There are like the very standard patterns to solve certain things. There are like different techniques. But in the end, in terms of real world, okay, there are cases where we do use algorithm questions, right? Like algorithms to kind of like speed out the process and stuff like that. But I don't think it's that important compared to, I think understanding how the developer think through the ERD and the component plan exercise is sufficient enough to judge whether the engineer is fit for the job or not. Instead of asking them to go and train a few weeks on algorithm questions, then testing algorithm questions, and after that you ask them to do like component design, right? Like it's a very different.
That's basically what happens at so many places. Yeah.
Yeah, it is, but I don't think. I mean, in some ways, it's just an intelligence test, right? In a way, right? Like, do you know how to do recursive function, for example? Do you know how to do like dynamic programming? That kind of stuff. But it's just sometimes it's very similar to a degree, for example, right? Like it's just a way to show that you can go through this kind of rigor, and then you can get a good result out of it. But it doesn't really translate directly to the actual skills that you need. So at least for watchTowr right now, at least for junior engineers, we don't really run with those questions. Yeah.
Really appreciate that insight. I think that's helpful for a lot of us who are applying or going to be applying for jobs soon.
Yeah, but if the company that you want is asking you algorithm questions, then you gotta train for it, right?
Yeah. Unfortunately, we still see a lot of that. Yeah.
Yeah.
Okay. Ray has a question about some of the stuff you were mentioning earlier about how the product works. Maybe we're running close to the hour, so just have this one question. How much human intervention is required when there's an alert in watchTowr's product? Ray, and feel free to add on.
Yeah, I'm basically asking this because I had a contact of a previous friend. I don't know his exact role, but he was involved in cybersecurity. This is not really like work-life balance question. It's more like I would like to know how it works and whether the human reliance and the human factor still remains as with normal other cybersecurity solutions, like companies involved in cybersecurity. So basically, they had teams on standby, like they had to be rostered and all the way through the month, like every single day, and that kind of thing. So with watchTowr, how does this kind of work arrangement or like deployment change? I suppose there still needs to be human intervention, right? So I mean, like a human person there is standby, right?
Yeah. So to answer that, sorry. Yeah.
Sorry, that's my question actually. Yeah.
Okay. Sure. So to answer that, I mean, 100%, I cannot guarantee that there's no human involved, right? Because sometimes if it's a fully new vulnerability, and then we don't have any tooling that is in place to test it, then we need to kind of write that code. But one thing that we have that we can leverage at watchTowr is the way we collect data about our clients. So an example is, let's say, for example, you're running node servers, right? If you look at if you Google Node CVE, there's an entire list of vulnerabilities that Node have based on the version of the server that you're running. Right. So let's say, for example, if a CVE drops on Node 14.1.1, for example, right? Our servers, because we already collect information about the company, already know if anyone is running that Node version. So if that, for that vulnerability, you know that your clients are not vulnerable. But this is a very simple check in a way. We just check the technology version first, and after that we can check other techniques. So in areas where we can automate, or in areas where we have a data lake built up on the specific technique, that we don't need to be on standby all the time because we have that process in place. But of course, if it's like brand new stuff, right? Like, for example, not related to any version, for example, like let's say Notion is breached. And then like our clients are running Notion, and then they want to know whether they are vulnerable or not. So we might need to we might do some manual checks first to check whether they are vulnerable, and after that we automate that into a process that will always check whether they're vulnerable moving forward. So speed is definitely something that that we need to be faster than our clients, because it's a value proposition that we provide, right? Like if you're a cybersecurity company, you need to always be ahead of the attackers. And if you take 1 week to respond to a vulnerability, then it's 1 week that the clients are vulnerable. So definitely we have some form of monitoring in place that will kind of like check when the vulnerabilities are published, and we need to react accordingly. Yeah, because the vulnerabilities can be published anytime, and they can be highly critical, very similar to the Confluence ones that we had yesterday night.